Okay, so we've got to do what we already know how to do, but we have to do it backwards. So we're going to write a sine equation and a cosine equation. Now, you might be a little bit curious as to how one curve can be both functions. How can one picture represent two different equations? Well, what's your thought on that? How could this thing represent two different equations? Anybody have a thought? Okay, so there's the picture that's drawn. Why could that be both a sine or a cosine? Exactly. Remember, you're allowed to pick these things up and move them around, right? So it is possible that you have a sine curve. Sine curves are supposed to start here, remember? They're supposed to start here and look like this. But if you picked that up and shifted it, wouldn't this be a sine curve if I look at that piece right there? That would be a sine curve. But if I look at this piece right here, between my hands, that would be a cosine curve. Now I'm going to start with that one because that is a cosine curve. There's no shift involved with that. So I'm going to start with that. And you'll recall that when you look at a cosine equation, there are 4 potential places to put numbers into the problem. The reason that there are 4 places to put numbers into the problem is there are 4 transformations that can happen, 4 ways to change the picture. You can put a number out here in front that does what? Changes the height, amplitude. You can put a number here that does what? Changes the width, changes the period. You can put a number here that does what? Shifts you left and right, and you can put one here that shifts you up and down. Now, that isn't to say that every equation is going to have all 4 numbers, but you could have those 4 numbers, right? So your job is to fill in all the blanks for this picture. All right? Now, tell me one of the blanks. Can you fill in any of the blanks? In the beginning, we have a 2. That amplitude is 2. The picture's been doubled. It's twice as tall as it was. Got it? That's easy. Can you fill in any of the other blanks?
6.
Can you fill in any of the rest of them?
5 or 6.
No, there's no 1/6 in this one. Let's do the easy ones
Just
first.
6.
If this is a cosine, how have we shifted it? We haven't. How about up and down? We haven't. So those 2 are zeros. Now, you're struggling a little bit with the period part. The period is from high point to high point, from hill to hill. What is your period? 4 pi over 6. Now you know that to find the period of any sine or cosine, don't you take 2 pi and divide it by that number? Remember all that stuff with sinusoidal and all that? How did we find the period every time we did it? 2 pi divided by that number. Now, I don't know what that number is, but I know the period is 4 pi over 6. From the picture, high point to high point is 4 pi over 6. So 4 pi over 6 equals 2 pi over n. And now I'll solve. I'm just doing it backwards of how I normally do. So what number goes up there? What's n? 3. That's a 3. So if you want, I'm perfectly okay with that equation, but if you wanted, you could just write it as 2 cosine 3x, right? That's all we have? Everything else was 0?
Yeah.
Now, here's the good news. When I think about, now I gotta write a sine equation. When I think about the sine equation, I'm looking at this part of the curve. Would you agree with me, the purple part? Is the amplitude any different? Amplitude different? Period different? Vertical shift different? No. So when I go to write this sine equation, every number is going to stay the same except that one. Because you told me, the only difference between seeing a cosine curve and a sine curve is how you have shifted it. And that shows up only in this blank. So all the rest of it's going to stay exactly the same every time. The only thing that's going to change is right here. Where are you starting? Well, where are we starting if we're thinking of this as a sine curve? At negative, we backed up pi over 6, so this would have to be x plus pi over 6. That would back you up pi over 6. Now, I don't know, did anybody look at this picture and see this? Would that be a sine equation? Yes, but it's upside down, which means when I wrote it, I'd have to have a negative 2 out here, because it's upside down. And instead of shifting pi over 6 to the left, I want pi over 6 to the right, so this would be x minus pi over 6. Okay, I'm done with this problem, but I just want to point out, could somebody else look at it and see this part? And you could write an equation for that part. And somebody else could see another part or another part. There are infinitely many answers to this question. But they're all going to have the same coefficient out here, sometimes negative. They're all going to have the same coefficient here, and they're all going to have the same vertical shift. This is what, where am I starting? Where am I looking?
So with the negative 2 sine of 3x minus cos of x here's the graph of that.
No, the purple one is this one, the red one is this one. They're the same graph, there's no mirror. They are exactly the same graph, just different, yes, yes, just different pieces of it. If I choose to look at a piece that's upside down, then I would have to write a negative in front of my equation.
But for the whole graph, you're supposed to have the top one.
Oh, there are infinitely many answers. You have to have one cosine equation and one sine equation. These are both sines, so you would only have one of these down here. And there's tons of cosine ones. You just pick one. Now, anytime it starts on the axis, I mean, I just like to use that one because it's not shifted. But you could use this one, you could use this one. There are lots of different options.
And either of the sine ones would work?
Yes, because it's all the same picture, right? Okay, so that's that. On one of the worksheets, there's another one like that. So we can, let's just go ahead and do that right now. Get out your review packet, and I don't have any extras. This was given to you at the same time that you got your big packet, so I know you have it. It's 3 stapled sheets, it's review. It says review sheet at the top.
Is that from last semester?
3 sheets stapled together, it says review sheet at the top. And this is number 12 on that front sheet. And I'm going to go ahead and do, the second one, problem B, because it's a little bit different.
Oh.
If you can't find yours, take a picture of somebody else's.
Oh, I got it.
You can get your phone out and take a picture of somebody else. Okay. So here we go. This is the same exact exercise. We're going to write the equation, or equations. We're going to do a cosine equation and a sine equation of this problem. So we have to figure out the four numbers that go into the problem. Knowing that the only one that's going to change here between these two, the only one that's going to change is right here, because you'll be looking at a different piece of the curve. So, what do you want to start with? Doesn't matter, just pick one. You want to do sine or cosine?
Sine.
Sine. If I'm doing a sine curve, Charlie, I think that's a great choice. This would be a sine curve. Would you agree with that? Now, there are other sine curves you could look at. I could spend the next 5 weeks on this one problem because there are infinitely many answers. I'm just picking one. I picked purple. So we're doing the sine curve. Now, anybody know any numbers that go in that equation for the sine, for the purple sine curve? Any numbers?
4.
Where do I put the 4? Out in front? The amplitude is 4. I don't think so. I don't think the amplitude's 4. I think the amplitude is 2. How tall are these waves, kids? They're not 4 tall. How tall are the waves?
2. Oh.
The waves are going up and down 2. Now, 4 is something. What's 4? 4 is the new axis,
It's plus 4.
which means that whole picture has been moved up 4 units. So the 4 goes out here. You have picked it up 4. If it helps you draw that axis in, you can see then you're only going up 2 and down 2, right? That's your amplitude. All right? If you're looking at the purple curve, how far have you shifted it? You haven't. You haven't shifted it. Doesn't a sine curve start right here at the origin? Yep. There's no phase shift here. You haven't shifted it at all. Now, this is a period. What is your period? 4 pi over 8. I'm going to go ahead and reduce that. That would be pi over 2. So your period is pi over 2. And we know we find period by taking 2 pi and dividing it by that coefficient. So what does that coefficient have to be in order to have a period of, oh yeah, has to be 4? What's 2 pi divided by 4? Half. Isn't that your period? Half. So there it is. There's your sine equation. Now the cosine equation is going to have all of these numbers exactly the same. But now I have to find a cosine picture in there. Cosines either start at the, well, positive cosines start at the top of the hill. Negative cosines start at the bottom of the valley. You can start in either one. So you want to start at pi over 8. And then this would be your cosine curve. It's the same height, the same everything, except you're starting not at 0, but at pi over 8. So your cosine curve would be x plus or minus? Minus. Remember, x minus pi over 8 shifts you to the right. Got it? Okay. All right, now let's look at a couple of questions from 4.8. Those of you working on homework, which is due tomorrow. 4.8.
Dude, that was hilarious.
That was funny.
That was like they heard it, but they didn't want to hear it.
All right.
I can't believe I got through.
You stand there for a minute.
Anybody have a 4.8 issue? 4.8 problem. Heavy. 16.
Oh, they did this all the time. Really.
Did I already do that one? All right, let's pick a different one. No one do 16 over again. Huh? I think they're all good. Here we go. I'm not going to stand here and wait. If you've been working on this, you got a plan. If you haven't been working on it, oh Lord.
No,
Mary Margaret. 26. All right, so we're doing problem number 26. Milwaukee, Wisconsin is directly west of Grand Haven, Michigan, on opposite sides of Lake Michigan. Okay, well, they give you lots of information, but the deal is you have Milwaukee, or no, you have Grand Haven and Milwaukee is directly west of Grand Haven. On a foggy night, a law enforcement boat leaves from Milwaukee on a course of 105. So I'm doing a course, I'm going to set my compass point here. And a course of 105, remember we measure from due north. So this would be a course of 105. Would you agree with me?
Yep.
So you've got the good guys, law enforcement, on a course of 105, they've left from Milwaukee. At the same time, the bad guys, the smugglers, are steering a course of 195 from Grand Haven. So now we're at Grand Haven, and we need a course of 195, which would be over here. So here are the bad guys, leaving on a course of 195. All right. Now, what's going to happen at some point? The good guys are going to get the bad guys, right? The law enforcement boat averages 23 knots. A knot is a nautical mile per hour. It's a speed. When you say someone is traveling at 23 knots, it's 23 nautical miles per hour and collides with the smuggling craft. What was the smuggling boat's average speed? So I don't know how long they traveled. So I'm just going to call this 23 and this X. Now, technically, this would be 23H and XH because the actual distance is going to be rate times time. But to keep it, they're in the same ratio because they're traveling the same amount of hours. So to keep it simple, I'm just going to let H be 1. Those factors are going to cancel out anyway because I'm going to set up a trig ratio and put one over the other and they're going to be gone. So I'm going to pretend it's 1 hour, this guy's gone 23, this guy's gone X. Now, in order to solve that triangle, I'm going to have to know something about the angles. So can anybody tell me anything about this angle right here, the red one? 15. We know it's 15, right? Because the whole thing is 105, and the quadrant 1 is 90. And then, can we do something similar with this angle right here? What would that angle be? 75. The stars are aligned. Because if that's 15 and that's 75, because this is 270, then this guy has to be 90. So there's our right triangle. It's a little bit warped. I mean, I didn't draw it quite right. It's a right triangle. This side over here would be which side? Opposite, adjacent, or hypotenuse? That's hypotenuse. So depending on which angle you use, let's use 15. 15, this would be the opposite and this would be the adjacent, right? If we use 15. So we can say tan 15 equals x over 23. So x equals 23 tan 15. And I'll go type it in and come up with an answer. And the unit on that would be knots. That's how many miles per hour this smuggler is going. Hey, Griffin, I don't write the problems, I just read them. All right, one more. One more from 4.8. Anybody got one? Last call. 9. Cloud height. To measure the height of a cloud, you place a bright searchlight directly below the cloud and shine the beam straight up. So, here's the cloud, and I'm standing down here and I'm shining my beam straight up at the cloud. This is the cloud. From a point 100 feet away from the searchlight, here's the light shining up. From a point 100 feet away, you measure the angle of elevation to be 8312. So the angle of elevation is 8312. How high up is the cloud? When you read the whole problem, which you should always do, read the whole thing. But if you look at the whole problem, it's kind of overwhelming. But when you take it, one phrase at a time, it's not too bad. So, what function? Tangent. So, tan 8312 equals x over 100. So, x equals 100 tangent 8312. Everybody okay with that? Type it in your calculator. Remember how to type that in? 83 second apps degrees, 12 second apps minutes. There you go. Okay. All right. I have started review sheet 4. In another class, so I think I'm going to start a different one with you guys. They're all the same, so it doesn't really matter. So, let's look at the sheet called Pretest. So it's the second sheet of your review packet. Again, if you don't have one, take a picture of somebody's. So I've got a thing called Pretest Chapter 4. And let's see how much of this we can get done. And next time we have class, I'll finish it if you remind me. This is in your review packet, which has 3 pages. The top sheet says review sheet. The next sheet is Pretest Chapter 4. Okay, if you can't find it, just take a picture of somebody's. Chandler, are you with us?
Yeah, I am.
No, you're not.
This is the right page, correct?
Yep, it is. You're right. All right, so here we go.
It's early.
Here we go. It's early. Well, maybe for you guys it's early. All right, given that this is the cosine and this is the neighborhood that we are in, we want to find the other 5 functions. Well, the other 5 would be sine, let's see, cosine's given, tangent, cosecant, secant, and cotangent. So if we know the cosine is -2/7, then the secant must be -7x. Everybody gets that point, right? Automatic. Now, what do you think we ought to do?
Make a triangle.
Make a triangle. And the triangle we make is going to be where?
It's gonna be 2, 4. 1.
I heard 2, 4,
It's gonna be
1, and 3.
4.
This tells me where it fits. What's pi?
180.
Pi is 180. What's 3 pi over 2? 270. Where's the quadrant that's between 180 and 270? It's quadrant 3. This tells you where you are. This is 180, this is 270. You're somewhere between those. They don't make it hard. That's easy. They tell you. You're in quadrant 3. Now, the cosine is -2/7. Adjacent over hypotenuse. So now what?
Find the missing side.
Pythagorean theorem. Find the missing side. Pythagorean theorem. So let's see. What's that going to be? 49 minus 4. Square root of 45, which I'm going to go ahead and simplify right now. 3 root 5. Now wait. That 3 root 5 needs to be negative. Pythagorean theorem, a squared plus b squared equals c squared. C squared is always the hypotenuse. Great. You know what I'm going to say.
Yeah.
What story are you going to tell me this time?
Got a little off task.
Just a little off task. Okay, let's stay on task.
Come on, buddy.
Otherwise, we'll have a takedown and I'll pin you to the mat. How about
Ooh.
that? Okay. Here we go. Here we go. Fill in the rest of them. What's the sign? -3 root 5 over 7. Perfect. Which means the cosecant will be 7 over -3 root 5. But you got to multiply by the root 5. So we have -7 root 5 over what? What's down here? What root 5 times root 5? 5 times 3? 15. There we go. Let's not make it hard. Let's not make it hard. What? When you write a negative fraction, you can put the negative anywhere.
I didn't see
you
the
want.
negative over the second.
Yeah. So it can be. I like to put it at the top personally, but it doesn't matter. Tangent. We're going to have a similar issue with the tangent. Here we go. What's the tangent of that angle? 3 root 5 over 2. But the cotangent then would be 2 over 3 root 5. You can't have it this, right? So we're going to multiply by root 5. So we have 2 root 5 over 15. Ready? Now, the ones with stars are calculator problems. So let's go through and do all the non-calculators first. Or would you rather do them in order? Is it easier for you if you do them in order?
Yeah.
All right, let's do number 2 then. We need a calculator. And since we are evaluating the secant of 11 pi over 7, our calculator needs to be set in radians. 11 pi over 7 is a radian measure. Agreed?
Yes.
So my calculator, I'm going to put 11 pi over 7 into my calculator. It needs to be in radians. Now, I would love to be able to press secant, 11 pi over 7, but I don't have that button. So who remembers how I type secant into my calculator? 1 divided by cosine. Isn't that what secant is?
Yeah.
So I literally type 1 divided by cosine, 11 pi divided by 7. And your answer should be 4.494. Anybody not get 4.494? Change it to radians and type what I have on the board. 1 divided by cosine, 11 pi divided by 7 equals. Quentin, where's your calculator? Good. Did you type that in already?
Not yet.
Just write down the problem.
You and Brady tell great stories.
Actually was.
All right. Next. What does the next problem want me to do? Find the angle whose tangent is negative 2/3. So I'm going to go ahead and type that. Second tangent, negative 2/3. I can just type that straight in. I have this button. Type it straight in. And I get negative 0.5888. What is the unit on that negative 5.888?
What did I say?
Radians. Why did I get a radian answer? Because my calculator is set in radians.
I thought it was supposed to be the degrees.
No,
Dude.
it's not. Okay, not supposed to be. Could it be? Yeah.
Where's my brain exploding?
If you wanted to change your calculator into degrees, you're going to get a totally different answer.
Digit error.
No, you shouldn't get error.
I got the wrong answer because of that.
You get negative 33.69 degrees. Now, there are no directions here. There are no directions for that problem. So either one of these answers would be completely acceptable. What if you are inputting an angle, you have to be in the mode of that angle. So when I was inputting 11 pi over 7, when I was typing that into my calculator, it had to be in radians because that's a radian. But what's happening here? An angle is coming out. And it'll come out however you tell the calculator to have it come out. If you're in radians, it'll come out as a radian. If you're in degrees, it'll come out as a degree. It doesn't matter to me unless the directions say answer in radians or answer in degrees. Otherwise, it makes no difference. Those are both right answers. And we don't have to do anything fancy because you have that button. Just press it. Okay. Now, no calculator, and we're going to sketch. This is what we did at the beginning of the period, but at the beginning of the period we were going backwards. We had the sketch. Now you are going to sketch it. So all the numbers are there. So you can see what your amplitude, period, phase shift, vertical shift, and frequency are. All the numbers are there. What's your amplitude? 2, which means when we get ready to graph it, we're going to go up and down 2. What's your period? So it's 2 pi over 2, which is pi. That means from when I draw my sine curve, from here to here is going to be pi. One hill and one valley makes pi. What's my phase shift? How far have I shifted?
Pi over 4.
Pi over 4 to the right. Positive pi over 4 indicates right. What's my vertical shift? Don't have one. That means my curve is situated right on the x-axis. What's my frequency?
1 over pi.
1 over pi. Frequency is the reciprocal of the period. Alright, so now we're ready to sketch. We got all the facts. The curve is going to start at pi over 4. It is a regular sine curve. So I have my hill and my valley. And there's my stopping point, your start to stop. And I know that distance is pi. You figured that out. The period is pi. So now we got to figure out the end point. What will the end point be? Not pi.
2 pi. 2 pi. 1 half. No, it'd be,
Somebody said 5 pi over 4. Whoever said that is exactly right. Now, those of you that are struggling with this, stop it. You're starting at a 4th, and you're moving forward 1. So where are you going to end up? 1/4 plus 1. 1/4 plus 1, which is what? 1 1/4, or I prefer 5/4. Because I know I'm going to have to be doing some arithmetic, and it's going to be easier to have it as a fraction. We're starting at a 4th, and we're traveling 1. So now we're going to be at 1 1/4. What's the matter with you? What's the matter?
It smells really bad over here.
Alright, let's try to be mature. Alright, so we're starting at a 4th, ending at 5/4. This is the halfway point. What is halfway between 1 and 5? 3. Now those are easy enough numbers. You might have just said, oh, that's 3. Remember, you're averaging. 1 plus 5 is 6, and half of 6 is 3. You're finding the midpoint. You're averaging. Now we're going to do the same thing here. 1 and 3 makes 4, and half of 4 is 2. I know it reduces. You don't have to. You can if you want. Then we want the minimum point, the low point. 3 and 5 makes 8, and half of 8 is 4. And there is your picture. Find the exact value of the tangent of 2 pi over 3. Switching gears. This is not a graph. This is going to be a number, a fraction, opposite over adjacent. What do we need to do to get started on this? Turn it into degrees. That's easy. Pi is 180 divided by 3 is 60 times 2 is 120. So now we've got it in degrees. We're changing it into degrees. Got it done. Now what do? Draw it. And we don't graph it like this. We draw it 120 degrees, right? Which would be over here. Butterfly bow tie. This is 120 degrees.
660.
So the reference angle, that angle at the origin, remember you always need the angle at the origin inside the triangle, that's 60. So immediately then, root 3, 1, and 2, because that's a 30, 60, 90, and what did you say? You got a negative on the 1. Pay attention to that. You do not want to forget any triangle sitting in a quadrant other than 1 is going to have negatives somewhere. Tangent, by definition, opposite over adjacent, so the answer is negative root 3. Root 3 over negative 1 or negative root 3. We're going to do number 5. You are not escaping yet. We're going to do number 5.
One more.
One more. Hang in there. And we all go trampling out of the room like a herd of wild wolves. Alright. So we have a 140-degree angle in a circle with a radius of 2. And we're finding the area. Alright, we talked about this last time. We don't want the whole area. The whole area would be pi r squared, or 4 pi. We don't want half of it. We want a fraction of it. And what is the fraction that we want? 140 over 360. That is the fraction of the whole. So these will cancel. 4 goes into here 9 times. I think it's 14 pi over 9. What do you think? And the unit on that would be square inches. The radius was 2 inches. Area is square inches. Got it?
Got it, jeez.
All right, I will see you people tomorrow, and the first thing we do is take a quiz. No talking me out of it tomorrow.
Hey, what's it? Is it all right?
It's over the mini reviews. I picked 5 problems out of the mini reviews. I think I already told you that, but oh well.